Part 1. What is sleep? Sleep is the single most effective thing we can do to reset our brain and body health each day. Mother Nature's best effort yet at contra death. Matthew Walker. Sleep architecture. Let's go on a journey through the sleep cycle and become familiar with the stages and core components of sleep. Every night when you close your eyes and gently drift away from the land of wakefulness and into sleep, you go on a magical journey. Our journey begins at the gateway to slumber, otherwise known as Stage 1, the lightest stage of sleep. Stage 1 occurs right after you fall asleep, and you'll usually spend less than 10 minutes here. You are dipping your toes into the void of sleep. When you're here, you're in a very light sleep from which you can be awakened easily. Here you experience the gentle transition from the world of wakefulness into the realm of sleep. As we dive deeper, we reach Stage 2, the fortress of silence. Your body enters a more subdued state. Your temperature drops, your muscles become more relaxed, and your breathing and heart rate slow down. At the same time, your brainwaves show a new pattern and your eye movement stops. When you're here in Stage 2, on the whole, brain activity slows. But there are short bursts of activity. Here the brain produces sleep spindles and K complexes. These phenomena, like magic spells, not only help to decrease sensory inputs, protecting your sleep, but also aid in memory consolidation and information processing. Someone with a higher frequency of sleep spindles will be more resilient to outside noises and being awakened easily. You then travel even deeper, where you reach the mysterious realms of Stage 3 and Stage 4, the deepest stages of sleep. This is the land of restoration. Your brainwaves become even slower, your body tissues heal, your immune system restores, energy is replenished, and growth hormones are released. This is where your body heals and grows. If I were to wake you up right now, you would feel disorientated and groggy. If you don't spend enough time here in this stage, you will feel physically tired, your immune system will become weakened, and your cognitive function will decrease. Finally, you travel up out of the deep depths of Stage 3 and 4, pass again through the land of Stage 2, and arrive at the most magical part of your journey, the theater of dreams, rapid eye movement sleep, or REM sleep, where your dreams come alive. Here in REM, our brain activity is bustling with activity, creating the fantastical stories that you experience as dreams. Although dreams may occur in any sleep stage, this is where your dreams most frequently occur. The dreams in this stage are vivid and often bizarre. Your eyes are moving randomly and rapidly, your brainwaves become similar to those of when you're awake, and the muscles in your body become paralyzed, which keeps you safe and prevents you from acting out your dream in your sleep. Scientists believe REM sleep is vital for memory consolidation, learning, mood regulation, and creativity. This is the end of the cycle, and just like that, a new cycle begins, taking you on a magical journey again and again. The cycle repeats itself around every 90 minutes, until the morning light calls you back. If we look at 5 sleep cycles over 8 hours, it is important to notice the peculiar dynamic that occurs. The balance between deep sleep and REM sleep shifts over the course of the night. With each sleep cycle, deep sleep decreases and REM sleep increases. Most of your REM sleep will occur in the last few hours before you wake up. It is important to understand this dynamic because even a seemingly small reduction, say from 8 hours down to 6, could actually deprive you of up to 70% of your REM sleep. If you aren't spending enough time here in REM sleep, you can expect decreased concentration, irritability, mood swings, increased stress levels, reduced creativity, and reduced problem-solving ability. And that is the magical journey of a sleep cycle. Sleep isn't just a retreat from our busy lives, but a vital journey our body undertakes to keep us healthy, sharp, and ready for each new day. So tonight, as you close your eyes, remember the incredible adventure that awaits. Rhythm. 2 principal factors regulate your wakefulness and your need for sleep. Your internal circadian rhythm, also known as your body's 24-hour clock, and a chemical known as adenosine. The circadian rhythm dictates rhythmic patterns including moods, eating and drinking preferences, core body temperature, and hormone release, among other things. It even impacts processes like athletic performance and the timing of births and deaths. This internal clock operates in an approximately 24-hour cycle and communicates its daily circadian rhythm signal to every region of the brain and every organ in the body. It is produced by the suprachiasmatic nucleus in the brain, which uses light levels to calibrate your body clock. Studies have shown that every animal species, including humans, possess an endogenous circadian rhythm. This innate rhythm may be slightly longer or shorter than 24 hours depending on the species. For example, humans' internal clock averages at about 24 hours and 15 minutes. However, the most reliable external cue, daylight, helps to reset our internal timepiece back to exactly 24 hours daily. This internal rhythm is controlled by melatonin. Melatonin is a hormone produced in your brain that regulates sleep and wakefulness. Its release into the bloodstream typically begins at dusk, signaling to your body to prepare for sleep. This release is gradually reduced throughout the night, until the dawn sunlight cues your brain to halt the release. While daylight is the most dependable resetting signal for our biological clock, other recurring signals such as temperature changes and social interactions can also serve this purpose. Genetics. Your rhythm is not the same as mine. Our individual circadian rhythm differs due to our genetic makeup. Some people referred to as morning larks feel most energized in the morning, while others, the night owls, function best at night. The societal preference for daytime work often leads to misunderstandings about night owls, who may be misjudged as lazy. They often have to compensate for their unproductive workday by burning the midnight oil. Adenosine. Adenosine is the second key factor in sleep regulation. It progressively accumulates while you're awake, resulting in sleep pressure after being awake for 12 to 18 hours. This pressure decreases as you sleep and is generally fully purged after 8 hours of sleep. The consumption of caffeine can mitigate the effects of adenosine, but it does not prevent the chemical's buildup. This can lead to a dependency cycle, as you may feel worse once the effect of caffeine wears off. Moreover, consuming caffeine in the evening can disrupt your sleep, as 50% of it remains in your system 5 to 7 hours later. Both the circadian rhythm and adenosine work independently, powering your wake drive and sleep drive respectively. Throughout the day, adenosine levels increase, and as you sleep, adenosine levels decrease. Their combined effects make you feel wide awake at noon after a good night's sleep, as there's only a minor gap between the two drives. Conversely, a large gap between the two drives at 11 p.m. makes you feel the urge to sleep. The larger this gap becomes between the two drives, the more sleep pressure you will feel. Ultimately, understanding your sleep-wake cycle is paramount to maximizing your productivity and maintaining your health. Factors such as light exposure, caffeine intake, and awareness of your individual rhythm can significantly affect your sleep quality and overall well-being. Architecture of the brain for sleep. Let's briefly take a look at 7 parts of the brain that are related to sleep. 1. The suprachiasmatic nucleus, SCN. Located in the hypothalamus, the SCN controls the circadian rhythm, which we looked at earlier. It regulates the sleep-wake cycle by signaling other parts of the brain to release hormones, control body temperature, and perform other functions that can make a person feel sleepy or awake. 2. Pineal gland. The pineal gland, located deep in the center of the brain, produces the hormone melatonin when it's dark to help promote sleep. 3. Thalamus. Think of your thalamus as the gatekeeper between wakefulness and sleep. During most stages of sleep, the thalamus becomes quiet, letting you tune out the external world. But during REM sleep, the thalamus is active, sending cortex images, sounds, and other sensations that fill our dreams. 4. Hypothalamus. The hypothalamus contains neurons that control sleep and arousal and is an important part of the brain for sleep regulation. 5. Pons. Located in the brainstem, the pons contains neural pathways that connect the brain and the spinal cord. It has a significant role in generating REM sleep and is involved in the regulation of breathing, hearing, and taste. 6. Medulla. The medulla, also part of the brainstem, helps control autonomic functions like heart rate and blood pressure, which are essential for maintaining a state conducive to sleep. And 7. Basal forebrain. The basal forebrain promotes sleep and wakefulness. The release of adenosine by cells in the basal forebrain supports your sleep drive.